All right, guys. Number 19, and that's the last set of questions on the final exam review. Evaluate the integrals using substitution. We're going to be using U substitution. So remember, if we're taking the antiderivative of a composition function, f of g of x, and over here we have a g prime of x dx, we can use U substitution. We can say let U equal to g of x, then take the derivative of both sides, and we're under the assumption that g is a differentiable function. We say du over dx is equal to g prime of x. We can then multiply both sides by dx. So that means that du equals to g prime of x dx. As you can see here, the g of x is u, so plug the u into there. And the du is equal to g prime of x dx. Plug that in here as well. So that's going to be the integral of f of u du, and the antiderivative of lowercase f is going to be capital F of u. Don't forget about the plus c. What did u equal to? U equal to g of x. So the answer is going to be capital F of g of x plus c. Substitution is the inverse of the chain rule. It's doing the chain rule backwards. All right, let's do the first one. We have the integral of sine cubed of x times cosine of x dx. Let's play around with this a little bit. I want to rewrite this as the integral, and I'm going to write this as sine of x to the third power times cosine of x dx. Now I need to find out which one should be my u. Which one is my substitution? The one that is inside of another function makes sense to be u. Once again, the function that is inside another function makes perfect sense to be the u. So we're going to say that u is equal to sine of x. So let me draw my new integral. U is equal to sine. So instead of us having sine of x to the third, we're now going to have u to the third power. Now let's take the derivative of u to find du. Du is going to equal to the derivative of sine. And the derivative of sine is going to be cosine. Let's remember that derivative of sine of x is cosine of x. And we're going to put the dx next to that. Now you have an option. You can put du over dx, but we wind up multiplying both sides by dx anyway. So it doesn't really make any sense to keep putting du over dx when we can just put the dx next to the other side as multiplication. Anyways, now that we see the cosine x dx, that is in the place of du. So we're going to write that as du. Now the integral is in the terms of u. And we're going to take the antiderivative by adding, let's make this green actually, adding 1 to the exponent, and dividing that by 3 plus 1. When you take the antiderivative, remember to drop the integral sign. That's going to be u to the power of 4 over 4. And don't forget to add your plus c. The original variable is in terms of x. Our answer right now is in terms of u. But remember, u is equal to sine of x. So don't forget to replace the u back inside. So that's going to equal to sine of x to the 4th power divided by 4 plus c. You can leave the answer like this if you want to, or you can write that as sine to the 4x over 4 plus c. And that is it. For this question, at least. All right, guys. Hope that made sense. Hope you was able to follow along. Let's do another one. It says the integral of x squared times the square root of 1 plus 4x cubed dx. Now remember, we're using substitution, and u is going to be the inside. So before I take any substitution, I want to rearrange the order of my terms inside of my integral. I'm going to write this as the integral of the square root of 1 plus 4x cubed. And over here, we're going to have times x squared dx. Now, let's perform substitution. Let u equal to 1 plus 4x cubed. So I'm going to go to my integral. It's going to be the square root of u. Let's take the derivative of u. So du is equal to the derivative of 1 is 0 plus the derivative of 4x cubed. That's going to be 12x squared. And remember to put your dx. Going back to the integral, we have an x squared dx. We have an x squared dx right here. However, there's a 12 in front of that. That's an easy fix. We can divide both sides by 12. And when we do that, we're going to have 1 over 12 du. And that's going to equal to x squared dx. So the x squared dx that is right here, that is equal to 1 over 12 du. So that's going to be times 1 over 12 du. You can move the 1/12 to the outside because it's just a coefficient. So 1/12 integral. I'm going to rewrite this as u to the power of 1/2 du. And then take my antiderivative. Add 1 to the power, divide that by 1/2 plus 1. That is going to equal to 1/12. That is going to be times u 1/2 plus 1 is the same thing as saying 1/2 plus 2 over 2. 1/2 plus 2 over 2 is 3/2. So that's going to be u to the 3/2. And that's divided by 3/2. Let's clean that up by utilizing keep, change, flip. Keep the 1/2 in front right here, or the 1/12, excuse me, times. Keep the top, which is going to be u to the 3/2. Change this division to multiplication. Flip the second fraction to make that 2/3. Simplify even further, because 2 and 12 can simplify. 2 goes into itself once. 2 goes into 12 6 times. 1 times 1, that's 1. 6 times 3, 18. Remember, u is equal to 1 plus 4x cubed. So we're going to replace the u with 1 plus 4x cubed. Remember, this is raised to the 3/2. And don't forget about your plus c. And that is the answer to this question. All right, let's keep going. This one, probably one that you're going to see on your final exam for sure. It says the integral of inverse tangent of x divided by 1 plus x squared dx. We want to solve this by using substitution. What I'm going to do is, maybe you don't see it, but I know I see it because I made the question. I'm just going to break this up a little bit. Now, remember, you can't break up the integral, but you can break up the terms in the integral as long as it doesn't violate any of the rules of algebra. So this can be equal to the integral. I'm going to write this as inverse tangent of x, or arctan if you want to call it that. And that's going to be times 1 over 1 plus x squared. I have my dx over here. And if you want to go back to the same thing, you can just put this over 1. Inverse tan times 1 is inverse tan. 1 times 1 plus x squared is just 1 plus x squared. Excuse me. But the reason why I did that is because we can see you have an inverse tan and a 1 over 1 plus x squared. Remember, the derivative of inverse tangent is equal to 1 over 1 plus x squared. So we can definitely use a substitution. We can say let u equal to inverse tangent of x. Let's draw a new integral. U is inverse tangent. Look, a crusty integral. Take the derivative of u. That is going to be du. And that's going to equal to the derivative of inverse tangent is 1 over 1 plus x squared. And then put the dx over here. And as you can see, we have that. We have a 1 over 1 plus x squared. We have a 1 over 1 plus x squared. So that part is just going to be du. Take the antiderivative. I don't want to use red. Let's use green. 1 plus 1. This is going to equal to u squared over 2. Put the 2 in green. And what does u squared equal to? Well, u is equal to inverse tangent of x. So we can write that as, in parentheses, inverse tangent of x. Remember, that is squared over 2. Let's make that a little bit more visible. And don't forget to put your plus c. That's it to the question. The fourth one, another likely candidate to be in your exam. Integral of natural log of x to the 11th power divided by 2x dx. Break that up again. Now, the 2 down here represents 1/2. Put the 1 in red. So I can move the 1/2 to the outside of the integral. So that's going to be 1/2 on the outside. The integral, I'm going to write my natural log of x to the 11th over here. And then I'm going to write that's just going to be 1 over x dx over here. And what do you know? Look at it. We know that the derivative of the natural log of x equals to 1 over x. We can say let u equal to the natural log of x, also because that's the inside part. So now let's draw a new integral. 1/2 integral. That is going to be u to the 11th power. Take the derivative of u. Du equals to the derivative of the natural log of x, which is going to be 1 over x, and put your dx over here. And as you can see, we have the 1 over x dx, and that's just going to be du. Take the antiderivative, keep the 1/2 in front. That's 1/2 times, that's going to be u to the 12th power over 12. At this point, you guys should know how to work that. Then we're going to have 1 over 24. Remember, u is the natural log of x. So natural log of x raised to the 12th power, and then plus c. And if you're asking where the 24 came from, 2 times 12 is 24. Excuse my Facebook. All right, let's do the last one. This one is a tough one, actually. This here says the integral of secant to the 10th x times tangent of x dx. Let's rewrite this as secant of x raised to the 10th times tangent of x dx. Once again, we said let the inside be the u. So let's let u equal to secant of x. So draw a new integral. So this is going to be u to the 10th. Take your derivative of that. Du equals to secant of x times tangent of x dx. Well, if you notice, I have a tangent of x dx but I don't have a secant of x times tangent of x. But pay attention to this. Watch this. Follow me. We just said let u equal to secant of x, right? And here we have du equals to secant of x times tangent of x. What I'm going to do is I'm going to divide both sides by secant of x. This simplifies. So we have du over secant of x. Keep that in black. And this is going to equal to tangent of x dx. But remember what I said before. U is equal to secant of x. There is a secant of x down here. So I can replace that with u. So du over u equals to tangent of x dx. And everything is in terms of u on the left side. So we can write our tangent of x dx as du divided by u. If I cancel 1 power of u down here, I cancel 1 power of u up here, which makes that u to the 9th. So that's going to be the integral of u to the 9th power times du. And then we can take the antiderivative. That's going to be u to the 10th power over 10 Remember, u is equal to secant of x. So that's going to be secant of x to the 10th power divided by 10 plus c. Or we can write that as secant to the 10th x over 10, or rather 1 over 10 times secant 10x, well, secant to the 10th power of x plus c. All right, guys, that's it for this video. Hope you enjoyed it. Hope you liked it. And I'll catch you in the next one. Well, actually, this is the last one. So good luck on the final. Take care.